Today we'll be discussing duplicate recessive epistasis. Let's consider the following pathway of the fictitious chameleon toads. All chameleon toads have a precursor color of red, though through the expression of enzyme 1 and 2, we can end up with an end product of the purple pigment. So, in order for the purple pigment to be phenotypically expressed, the dominant A allele needs to be present so that enzyme 1 can catalyze the production of the intermediate. In addition to this step, the dominant B allele needs to be present so that enzyme 2 can produce the end product, which is the purple pigment. But if the toad's genome contains the homozygous recessive A allele, the precursor will be phenotypically expressed because enzyme 1 will be inhibited. Let's say that the toad has one dominant A allele, but it has homozygous recessive B alleles. Well, with the one dominant A allele, enzyme 1 will lead to the production of the intermediate, but the homozygous recessive B alleles will inhibit enzyme 2, so that the end product will not be expressed, though the red intermediate will be. Let's say we cross two heterozygous individuals which are both phenotypically purple. If we look at the Punnett square that I've constructed, there are only two phenotypes which are expressed, which are purple and red. And by counting out these squares here, we can see that the phenotypic ratio is 1, 2, 3, 4, 5, 6, 7, 8, 9 purple for every 1, 2, 3, 4, 5, 6, 7 red. Although the genotypes allow us over here to see that there is a 9 to 3 to 3 to 1 proportion, which is definitely typical of duplicate recessive epistasis. Now let's say we cross these two individuals which are phenotypically red. I've done a 2 by 2 Punnett square since one parent is homozygous at the second loci and this parent over here is homozygous at the first loci. So the Punnett square here shows that there is a 3 to 1 phenotypic ratio of red to purple, though the phenotypes over here tell us that it is a 1 to 1 to 1 ratio.